13.8 billion years ago, the universe was born not with a shout, but with a whisper. A blinding spark of everything, blooming out of nothing. A breathless beginning, written in silence, veiled in light too young to be seen. In that first breath of time, physicists and cosmologists imagined a restless, chaotic nursery. A universe still fumbling for structure. No galaxies, no stars. Only raw hydrogen and helium drifting like unformed thoughts across a dark cosmic canvas. This is how we thought it all began, a slow unfolding. A quiet ramp toward complexity. The universe, infant and untamed. But then came James Webb, not with noise, but with vision. And what it saw did not whisper. It screamed. For decades, the dominant model of cosmology held a confident narrative. After the Big Bang, the universe would take time, hundreds of millions of years, to cool down, to stabilize, to create the scaffolding upon which the first stars and galaxies could eventually be built. The early epochs were imagined as a fog, filled with radiation and gas, dark, disordered. A cosmic infancy where matter was still learning to form bonds. Photons wandered without direction. Gravity was only beginning its sculpting work. The first stars, called population 3 stars, were thought to form after 200 million years. Only then could galaxies start taking shape, clumping together through gravitational attraction. In this model, seeing anything organized or complex in the first few 100 million years would be like seeing a house constructed before bricks had even been invented. But Webb had a different story to tell. When the James Webb Space Telescope turned its golden eye toward the earliest moments of the cosmos, peering deeper into space, and thus further into time than any telescope ever had, it unveiled a contradiction. Instead of shapeless gas clouds or chaotic blobs of matter, Webb found mature galaxies. Galaxies with well-defined structure. Galaxies glowing brightly with stars, some already rich in heavier elements like oxygen, carbon, and nitrogen. Galaxies hosting supermassive black holes and spinning in organized harmony. And these weren't seen after billions of years of evolution. They appeared just 300 to 400 million years after the Big Bang. In cosmic time, that's less than a heartbeat. The equivalent of a toddler reciting Shakespeare before learning to crawl. It's like entering a garden that was planted yesterday and finding it already filled with ancient oak trees, each one with rings older than the soil itself, or stumbling into a nursery and discovering philosophers, musicians, and architects all resting in the bodies of newborns. Everything we thought we knew about cosmic evolution, the pacing, the order, the gradual crescendo from simplicity to complexity, was upended. Silence we expected in those early frames of the universe was instead filled with symphonies. So what does this mean? Does time itself behave differently at the cosmic scale? Perhaps the flow of time is not a steady river, but a fractal folding, expanding, contracting based on gravity, density, and unseen forces. Maybe some parts of the universe aged faster than others, like fruit ripening at different speeds under the same sun. Or maybe more profoundly, our models are built on assumptions that reflect human time, human logic, and human expectation. And in doing so, we've misread the rhythm of the universe. We expected the early cosmos to be a dim rehearsal, but it was already a performance rich, dazzling, and far ahead of schedule. The silence wasn't a pause. It was a prelude. The cosmos did not tiptoe into complexity, it leapt. And maybe, just maybe, that leap is telling us something deeper. That the universe is not a puzzle to be solved in linear steps, but a poem to be read all at once, out of order and full of mystery. Some galaxies shine with the weight of age, yet they belong to a universe barely out of the womb. Imagine holding a newborn in your arms, only to find their eyes filled with ancient knowledge, their gaze older than the stars. This is what the James Webb Space Telescope has forced us to confront, not just data, but impossibility made visible. In the deep past, where time had barely taken its first full breath, there exist galaxies so ordered, so elegant, so impossibly Complete, they defy the logic that has shaped cosmology for generations. The story of galaxy formation, as told by decades of theory and simulation, is a tale of turbulence and time. It begins with dark matter halos, invisible frameworks that cradle primordial gas, drawing hydrogen and helium into slowly spinning clouds. Over hundreds of millions of years, these clouds fragment, ignite stars, and finally coalesce into galaxies. But order does not come easily. Galactic disks, those beautiful spirals that grace our telescopes and textbooks, are thought to be fragile. They take billions of years to emerge from chaos. They require time for stars to settle into rotation, for collisions to subside, for gravitational dance partners to find rhythm. In the early universe, less than 1 billion years after the Big Bang, such stability was considered impossible. The cosmos, we thought, was still drunk on its own birth. Matter hadn't yet calmed. Gravity was still throwing punches. The idea of seeing spiral galaxies, ordered, symmetric, refined, was like expecting skyscrapers in a city still recovering from an earthquake. And then we looked. The James Webb Space Telescope, with its unprecedented ability to pierce the veils of ancient time, turned its gaze to the infant universe, and what it found was nothing short of heretical. There, in a cosmos less than 800 million years old, were spiral galaxies. Not crude clumps, not messy mergers, but structured, rotating disks, some with well-defined arms, the architectural signature of galactic maturity. These galaxies did not simply exist, they thrived. Some spun as fast as the Milky Way. Some were massive. Some harbored intricate star formation patterns, cosmic blueprints that suggested not chaos, but control. They were beautiful. They were forbidden, and they shouldn't have been there. It was like entering a kindergarten and discovering that the children had built cathedrals, vast, intricate structures of stained glass and flying buttresses, each one a monument to intellect and time. Except the architects had only just learned to speak. It was like toddlers drawing mandalas in the sand, each curve aligned with ancient geometry. We expected to find scribbles. We found masterpieces. The early universe was meant to be a sketchbook. Instead, it held paintings already framed. How does such order emerge so soon? Are our cosmic clocks broken, or have we misread the ingredients of structure itself? Perhaps spiral arms don't need billions of years to form. Perhaps they are more natural, more inevitable than we realized. Maybe the laws of gravity and fluid dynamics conspire, under just the right conditions, to sculpt order from chaos in near cosmic instants. Or maybe we are seeing something deeper. That time in the universe is not a universal rhythm, but a song that plays at different speeds in different places. What takes 1 billion years here may take 100 million there, under denser clouds, sharper gravitational wells, or unknown forces still unaccounted for. It forces us to reconsider the idea of too early. Perhaps early is a word that only makes sense inside human calendars. And perhaps the universe does not evolve the way we think it should, slowly, predictably, obedient to our expectations. Instead, it blooms in fits of brilliance. It writes symphonies in the silence between our models. The forbidden galaxies do more than rewrite a paragraph in our cosmology textbooks. They whisper something older than theory. That order does not always wait for permission. That beauty does not always need time to emerge. And that the cosmos, even in its youth, is capable of poetry. The universe was born in simplicity, a breath of hydrogen, a whisper of helium. In that first instant, there were no colors, no metals, no complexity. Just the two lightest elements, dancing in the newborn cosmos, waiting patiently for the machinery of time to begin its slow alchemy. Astronomers believe that the elements essential for planets, for oceans, for breathing carbon, oxygen, iron had to wait their turn. They were to be forged in the hearts of stars, born only after the first suns lived, aged, and died in fiery supernova. It was a sequence thought to be sacred. Hydrogen becomes stars, Stars become furnaces, and only through death comes the dust of life. The early universe, by all predictions, was supposed to be blank, a pale canvas, quiet and unmarked. The first galaxies, if any existed, would be chemically primitive, hydrogen-rich, metal-poor, and still gathering the ingredients that would someday allow complexity to flourish. But James Webb, the silent eye cast far across time, saw something else. In the faint light of galaxies over 13 billion years old, it found traces, not of hydrogen, but of the heavier king oxygen glowing in spectral lines, iron whispering in the starlight, carbon hiding in the spaces between heavy atoms. Too early. Too many. These galaxies, mere hundreds of millions of years after the Big Bang, already bore the fingerprints of chemical maturity. The elements we thought would arrive in the third or fourth act were somehow speaking in the prologue. It's as if a forest bloomed before its seeds were planted. As if the ink of life had already stained the canvas before the artist had picked up the brush. We had expected the universe to walk, and yet here it was, sprinting. These observations didn't show a few rogue atoms, scattered and rare. They revealed enrichment, a sign that these galaxies had already gone through cycles of stellar birth and death. That stars had already formed, burned, and exploded. That supernova had occurred not in a distant future, but in the universe's fragile youth. It raises a disquieting question. How fast can the cosmos create? Was there a phase of star formation more intense, more furious than we imagined, a cosmic firestorm that transformed hydrogen into complexity at breakneck speed? Or are we missing something fundamental? Is there a mechanism we've overlooked, a process by which heavy elements form outside the slow cycle of stellar life and death? Or perhaps most profoundly, creation itself is not as linear as we believe. Perhaps nature does not build neatly in chronological order. Perhaps, under certain cosmic conditions, meaning erupts all at once, not in steps, but in sudden harmonies, like a symphony that begins not with a single note, but with a full chord. Maybe the universe doesn't wait. Maybe it remembers how to become what it must before the instructions arrive, because heavy elements are not just technicalities in a chart, they are the bones of planets, the breath of animals, the spark of chemistry, and the ink of DNA. To find them so early is to find the seeds of life scattered across time before life itself could take root. It tells us that the cosmos was not just building stars. It was already preparing for consciousness, already dreaming, perhaps of eyes that could look back across space and wonder how such things came to be. So we are left with a paradox. The building blocks of life, appearing when the universe was still an infant too young to walk, yet already scripting poetry in atoms. This isn't just a revision to a timeline. It's a challenge to how we understand emergence. It forces us to ask whether the laws we believe govern the universe are truly fundamental, or merely local customs of a cosmos too vast to obey its own rules. In these ancient, chemically rich galaxies, we find a message not in language, but in light, a quiet defiance of order, a gentle rebellion against waiting. The universe, it seems, is not a slow learner. It is a prodigy, a poet in the cradle, a mind already stirring in the silence, and we made of those same heavy elements, born billions of years later, are perhaps not the end of the story, just another echo of a creation that has always known how to begin. They are the universe's deepest scars, regions where gravity has won the eternal war against light, where time bends and space collapses. Black holes, born, we once believed, only from the deaths of stars, or the chaotic merging of galactic giants, a slow accretion of mass over cosmic lifetimes. They were to be the elders of the cosmos, patient monsters who grew fat on the banquet of time, lurking at the centers of mature galaxies, long after the dust of creation had settled. But then came the eye that sees the ancient, the James Webb Space Telescope. And what it revealed was something impossible. Something terrifying. In the dim twilight of the universe's first billion years, When galaxies were still stammering into existence, it found them. Behemoths, supermassive black holes, millions, even billions of times the mass of our sun already. Fully formed, not the quiet seeds of future giants, but giants already. It was like finding skyscrapers before cities, cathedrals before congregations. Massive structures towering in a landscape that should still be wilderness. How? The laws of physics, or at least the ones we've sworn by, insist that black holes grow slowly. A star collapses. It becomes a black hole. That black hole feeds on gas, on dust, on stars that wander too close. Gradually, over billions of years, it grows from stellar mass to intermediate to supermassive. But Webb saw the final act before the play had even begun. In galaxies younger than 1 billion years, it detected the fingerprints of accreting monsters. Jets of energy, warped light, intense gravitational pull, signs of black holes, millions of solar masses wide. There hadn't been time to grow them. There hadn't even been time to build the galaxies they now inhabit. It shattered the timeline. Because if black holes of this scale existed in the earliest chapters of cosmic history, it meant that the universe was either far more efficient at birthing them than we thought, or that our story of cause and effect, of galaxy first, black hole second, is backwards. What if black holes don't come from galaxies? What if galaxies come from them? It's an unsettling proposition that these dark engines which do not emit light, which cannot be seen directly, which are defined by absence, might be the architects of the luminous spirals we marvel at in our telescopes. That before there were stars, before there were disks, before there was form, there was collapse, a point of infinite density, a gravitational seed around which the cosmos began to swirl. Theories are now emerging to match this radical idea. Perhaps black holes can form directly from collapsing gas clouds in the early universe, bypassing stars entirely. Or maybe the first moments after the Big Bang created conditions so dense, so extreme, that primordial black holes popped into existence before the first atoms even cooled. But even these possibilities raise new questions. How did they grow so fast? What fed them in a universe that was still mostly hydrogen mist? Could dark matter be involved, the unseen scaffold of the universe, offering a hidden feast? And if black holes came first, does that mean structure itself, galaxies, clusters, everything, is not built on light, but on darkness? It is a reversal that burns the mind. The lighthouse becomes the harbor. The shadow becomes the foundation. And we, children of stars, must now consider that the stars themselves may have danced to a darker rhythm. Drawn, perhaps, not by gravity alone, but by the pull of something deeper. A whisper in the fabric of space-time that said, fall. In ancient mythologies, monsters often lurk at the beginning of stories, dragons at the edge of maps, serpents in the cosmic sea. Perhaps the universe itself began with a monster, a creature of silence and collapse. And from its hunger, form was born. This is the poetry of the paradox, that the darkest things in the universe may have lit the way. That black holes which swallow light may have given birth to galaxies full of it. It is not the answers that haunt us, but the symmetry of the questions. Are we looking at the end in beginning? Are black holes the final product of cosmic evolution, or the first architects of structure? And if so, then what else have we misunderstood? Because when silence speaks first, everything that follows must listen. And the voice of the early universe, echoing through Webb's mirror, does not whisper. It roars with the gravity of giants born too soon. Spin is the rhythm of galaxies, the slow, majestic dance of matter woven into halos of light. Across billions of years, clouds of gas gather, collapse and coalesce, forming stars, forming systems, forming the spirals we admire through telescopes, arms curling outward like celestial brushstrokes. Galaxies don't just exist. They move, they spin. And in that spin is a story of gravity, of growth, of time unfolding in orderly rhythm. Or so we thought. The earliest galaxies, The ones born in the infancy of the cosmos were supposed to be chaotic. Messes, small, uneven, tumultuous, like cosmic toddlers stumbling in the dark, still figuring out how to form structure, let alone balance. According to the great models of cosmology, these early systems lacked the time to form ordered motion. Their stars should have zigzagged in all directions. Their gas clouds should have been wild and irregular. Rotation true, stable rotation would come later, after billions of years of mergers, growth, and calm. But Webb looked deeper. And what it saw spun with eerie grace. In the haze of the early universe, just a few 100 million years after the Big Bang, Webb detected galaxies moving with balance and speed. Rotating in organized disks, their motion smooth, their paths curved like arms in a cosmic pirouette. It was impossible to imagine a child not just walking, but sprinting. Not just scribbling, but composing symphonies. Galaxies that should be disordered were dancing in perfect rhythm. It was like newborns running before they'd even crawled. Astronomers measured their rotation curves, the velocity of stars orbiting their galactic centers, and found stability where there should have been turbulence. These galaxies weren't supposed to have enough mass, or time, or gravitational order to move like this. Yet here they were, elegant, symmetric, spinning. How? Some suggest that dark matter, the invisible scaffolding of the cosmos, might be denser or more clumpy in the early universe than we thought. Perhaps these galaxies formed in pockets of unusually rich gravitational support. Or maybe gravity itself, on cosmological scales, behaves in ways we haven't yet understood. Others propose that our models are simply too clean, that the universe is messier, more improvisational, less patient than we expected. That maybe galaxies don't need billions of years to settle down. Maybe they're capable of finding harmony much sooner, under the right conditions. But even those theories strain under the weight of the data, because this isn't just one anomaly. Webb has found multiple galaxies, across multiple epochs, spinning with coherence, patterns not noise, rhythm not chaos. It brings us to a deeper question. What is spin? Not just the motion, but the principle behind it. In physics, spin is angular momentum, the conservation of movement, born from the earliest moments of formation. But philosophically, spin is something more. It's order from chaos. It's the universe finding rhythm in its own turbulence. And if galaxies are spinning before they should, maybe the universe didn't evolve into order. Maybe it was born with it. Maybe structure isn't something the cosmos earns. Maybe it's something it carries folded into its fabric from the beginning, like a secret encoded in its first breath. Or perhaps we are staring into a mirror we've never recognized, because galaxies, like humans, seek balance. They gather, they spin, they evolve. But what if we've misunderstood the direction of their journey? We thought they began chaotic and ended organized. But what if their structure is not a result, but a starting point? A rhythm set not by age, but by initial conditions we haven't yet fathomed. A cosmic music that began before we could hear it. And here we are mid-verse trying to reconstruct the melody from scattered notes across space and time. There's something haunting in the idea that the youngest galaxies could move with more grace than the older ones, that the beginning may be more refined than the end. It challenges our most fundamental faith, that time is the great sculptor of beauty, because Webb is telling a different story. One where the earliest stars already know how to dance. One where galaxies do not stumble into balance, but arrive with it in hand. Are our models broken? Or is the universe reminding us that simplicity is not always at the beginning, that some mysteries are born complex, and maybe, just maybe, the spin of galaxies is not just a motion. It's a whisper, a message, a hint that the cosmos was always capable of elegance, not after chaos, but through it. So we stand, watching these ancient dancers moving to a rhythm older than light. And we ask ourselves not just how they spin, But why the universe taught them to waltz so soon? In the beginning, the universe was thought to be quiet. A soft glow, expanding into darkness, a cradle for stars, a nursery for galaxies. Cosmic infancy was imagined as peaceful, galaxies blooming slowly, drifting apart like petals on a gentle current, each one isolated, each one untouched. Time was their sculptor, distance their protector. The early universe, they said, was too young for chaos, too sparse for collisions, too soon for drama. Mergers, those cataclysmic entanglements where galaxies crash and fuse, were expected to unfold later, much later. After billions of years of cosmic drifting, gravitational pulls would gradually pull galaxies together. Only then would the ballet of destruction begin. Stars slung across space, black holes spiraling inward, gas clouds compressed into wild starbursts. But then came Webb. James Webb, the infrared eye that pierced the veil of time, looked back to when the universe was just 300 million years old. A flicker, a heartbeat after the Big Bang. And what it saw defied the script. Webb saw galaxies already crashing into one another, already dancing, colliding in tangled spirals of luminous dust. The gravitational bruises of their embrace lighting up space like fireworks in a newborn sky. It was supposed to be too early, too soon. Like finding a crumbling cathedral in a village not yet built. Two galaxies locked in an embrace, distorted, stretched, shredded, their spiral arms pulled like taffy, their gas clouds thrown into chaos, their black holes likely on a collision course. Hidden in the throbbing core of the merger, a ballroom where the dancers have already collided, before the music has even started. The implication is seismic. Because for galaxies to merge, they must already exist, not just as clouds, not just as infant clumps, but as formed galaxies with stars, with mass, with shape. And if they're colliding 300 million years after the Big Bang, it means they had to form even earlier. Perhaps within 100 million years. Perhaps faster than any model dared to predict. This isn't just about timing. It's about the violence at the origin. A universe we thought was gently assembling is instead a crucible of energy, tension, and rapid transformation. Some scientists suggest dense pockets of matter, primordial overdensities, may have fast-tracked galaxy formation. Others whisper about dark matter's role in shepherding these collisions, forming gravitational hubs that draw galaxies together before the universe had time to catch its breath. But maybe we've misunderstood something deeper. Maybe destruction isn't something that comes later. Maybe it's there from the start. Not as a consequence, but as a cause. Because in these galactic collisions, something beautiful happens. Gas clouds compress. Stars ignite in furious bursts. New shapes emerge. From the wreckage, larger galaxies, richer in complexity. Destruction begets creation. Chaos births order. The death of one form is the genesis of another. Like fire clearing a forest, only to make way for richer soil. Like stars collapsing, only to become black holes, and maybe, just maybe, entire universes. It's easy to think of the cosmos as a story of gradual assembly. A slow march from simplicity to complexity. But Webb shows us another possibility, that the universe is more like a storm than a sculpture. That its first chapters weren't whispers, but thunder. And maybe that's why we're here. Because galaxies collided. Because matter smashed into itself. Because fire and fury did not wait for permission, they acted. And from that action came everything we know, every star, every planet, every thought. Maybe the collisions weren't anomalies. Maybe they were the engine. So when we look up and see the grand spirals above us, Andromeda, the Milky Way, we're not seeing peace. We're seeing the aftermath of cosmic violence, of ancient wars that shaped the heavens. And in that realization is something profound, that creation and destruction are not opposites. They are the same act seen from different frames of time. The crash that ends a galaxy's form is also what makes the next possible. Perhaps the universe has always known this. Perhaps it's trying to tell us in the way stars are born from collapse, and galaxies rise from wreckage, that growth isn't gentle. It's wild, it's unforgiving. It's beautiful. Webb didn't just show us galaxies colliding. It showed us that even in the beginning, the universe wasn't waiting. It was already alive, already risking, already becoming, and maybe that's the lesson, that the most profound creations in galaxies, in life, in thought begin not with stillness, but with a crash. In the silence after the Big Bang, we imagined a universe still learning to breathe, scattered, formless, raw. Like ink spilled across parchment, gravity would gather the droplets over time, shaping islands of matter. Galaxies would drift into clusters, filaments would stretch like cosmic bridges, and immense voids would open between them, a slow, deliberate choreography of chaos evolving into structure. We called it the cosmic web, an immense lattice stretching across the universe. Threads of galaxies aligned in grand patterns too vast for human comprehension. And we believed it took billions of years to form, because structure, in our models, demands patience. Gravity works slowly, and the early universe? It was supposed to be noisy, disordered, a haze of potential without form. But James Webb, that quiet prophet of light, saw something different. As it looked deeper into time, beyond what Hubble could dream, Webb glimpsed the universe in its infancy. And what it saw shook the foundations of our understanding. That it wasn't chaos. It was pattern, not hints, not seeds, but actual strands, filaments of matter already stretching across space. Galaxies aligned, clusters forming, void-like gaps already yawning in the dark. The web wasn't emerging. It was already there. As if the blueprint of the cosmos wasn't something written over time, but something unveiled, already etched into the fabric of space. Imagine lifting the veil from a painting you believed was still being painted, only to find it complete. Imagine walking into a house you thought was under construction and discovering a fully furnished home. That's the scale of the shock. These filaments, many hundreds of millions of light years long, are not trivial features. They shape the motion of galaxies. They determine where matter gathers, where stars ignite, where black holes are born. They are the architecture of everything we know. And yet here they are, less than 1 billion years after the Big Bang, when matter was still cooling, stars still forming, and galaxies supposedly still fumbling toward order. How? Why? Some theorists scramble for new explanations. Maybe inflation, the mysterious burst of expansion that occurred fractions of a second after the Big Bang, imprinted not just randomness, but pattern on the quantum foam. Maybe dark matter, the silent scaffolding of the universe, shaped this web more decisively and earlier than we imagined. But the deeper question lingers. What if we've misunderstood the starting point? What if the universe didn't begin as chaos marching toward order? What if it began with order already embedded, not a destination, but a birthright? The implications are staggering. If the web was already there, then perhaps the universe didn't build itself in steps. Perhaps it remembered itself into existence, as though some underlying principle deeper than gravity, deeper than time, had already authored the plot. Not a blueprint written on a chalkboard, but something woven into the very grain of reality. A geometry that space itself was compelled to follow. And in that idea is something profoundly philosophical. We often think of progress in life, in science, in the cosmos as a climb, from mess to meaning, from noise to melody. But what if that arc is only a reflection of our perspective? What if the universe was always singing, we just hadn't learned to hear it yet? We thought we were witnessing the construction of a cosmic city, brick by brick, light by light. But maybe it's more like walking into a cathedral carved into a mountain, not built by hands, but revealed by erosion, already present in the stone. The cosmic web is not just a structure. It is a map, of gravity, of matter, and perhaps of something deeper, something ancestral. As if the universe was not improvising, but unfolding a memory older than time. So when Webb shows us filaments where only fog should be, when it reveals form where we expected formlessness, it is reminding us that the cosmos is not only stranger than we imagined. It may be more deliberate. Maybe the initial state of the universe wasn't a blank slate. Maybe it was a hidden manuscript, and Webb, with its golden mirror and patient eyes, is reading its first pages to us. A web already woven. A story already begun, not in chaos, but in symmetry. Not in randomness, but in rhythm. And in that realization, we are humbled, because perhaps we are not drifting aimlessly in a meaningless void. Perhaps we are living inside a pattern, a geometry vast enough to hold galaxies, and precise enough to birth consciousness. We are filaments too, connected, drawn together, written into the same fabric. The web is not just out there. It is within us. Time for us is a current flowing in one direction, steady and sure. Moments stack like bricks, one atop the other. First breath, then thought. First seed, then tree. We trust in this rhythm, cause, then effect. Birth, then becoming. It's how we understand stories, how we frame science, how we build meaning. Time is a line, stretching from a beginning toward an end, order arising from chaos, simplicity flowering into complexity. The universe, by this view, should be no different. In the beginning, a searing soup of particles too hot for atoms, too wild for stars. Then cooling, expansion, the long climb toward structure, galaxies blooming after hundreds of millions of years, stars clustering in cosmic cities, the architecture of the cosmos gradually sculpted by gravity's patient hand. But then came James Webb. And with it, a fracture in the timeline. Its mirrors peered into the darkness, not just space, but time itself, reaching back to the first few 100 million years. A baby universe, barely crawling. Yet what it found were galaxies not infant and chaotic, but mature, spinning with balance, entangled in mergers, aligned in vast webs. Stars already formed, dust already enriched, black holes already grown. It's as if the script had skipped ahead, like reading the final chapter of a novel before the first scene was set. Like walking into a theater and the curtain rises to a climax, because the long, slow growth of structure was missing. But the effect, a complex, organized cosmos, was already on display. This isn't just odd. It's a philosophical earthquake, because if time is sequence, and sequence is broken, then what is time? Are we wrong about its flow, about its direction, about its very nature? Webb's images whisper of a universe that doesn't follow our linear expectations. A cosmos where the arrow of time doesn't always point forward, where effects do not always wait for causes. Some theorists now wonder, is time more like a spiral than a line? A helix winding through dimensions we can't perceive, looping back, intersecting itself, writing chapters out of order? In quantum mechanics, we've already glimpsed hints of this. Particles that seem to know the future. Entangled twins influencing one another across distance, and maybe even across time. But now, the macroscopic universe, the realm of galaxies and gravity, appears to be joining the quantum in this strange dance. And that makes the question even more pressing. Are we just observing the universe out of sync, or is the universe itself out of sync? Maybe the early cosmos wasn't an empty stage, slowly populated over time. Maybe it was preloaded, encoded, ready to unfold its beauty far earlier than our clocks would allow. Some propose alternative cosmologies, bouncing universes, mirrored timelines, or even time as an emergent property, not a fundamental one. Ideas that challenge not just physics, but perception itself. Because what if the problem isn't the cosmos? What if it's us? Our minds evolved to see time as linear because that's how survival works. You eat after you hunt. You flee after you hear. The growl, linearity is logic, It is safety. It is sense. But the universe is not built for our survival. It is built for itself. So perhaps time, as we know it, is a limited metaphor, a scaffolding we place over reality, like lines on a globe. Useful, but not the whole picture, because what we now see is a universe where the expected order from simplicity to structure, from chaos to clarity, doesn't always hold, where chapters are shuffled, where finales come before prologues. And in that broken rhythm, there may be truth. Maybe the cosmos is telling a story we're only beginning to hear, one that bends and loops, twists and returns. A story not of straight paths, but of spirals, of echoes, of futures seated in the past. And maybe we too are part of that spiral, living in a moment that only seems to follow the one before it. What if time is not a river? What if it's a song? A melody that returns to familiar notes, but always in a new key? James Webb hasn't just shown us distant galaxies. It has handed us a mirror. And in it, we see a universe that defies our simplest truths, inviting us to rethink not just the cosmos, but time itself. Because perhaps in the great book of the universe, the pages are not numbered. They are layered, folded, timeless, and we are only just learning to read. We imagine the universe as a puzzle, one we could solve with enough equations, enough data, enough time. With chalk and silicon, we mapped the cosmos on blackboards and supercomputers. We gave it shape, age, structure. We charted its infancy, its expansion, and perhaps even its end. All from here, this pale, fragile dot suspended in a sunbeam. We built models, elegant, towering models. CDM, lambda, cold dark matter. A framework both simple and profound. It told us that galaxies form hierarchically, assembling over time like cities growing from villages. It told us that dark energy pushes the universe apart, and that gravity molds its skeleton. It told us that we understood, or at least, that we were close. We called it a standard model, as if the cosmos had agreed to our terms. But then came Webb, and with it light from the deep past. Not theories, not simulations, reality. And reality had other ideas. Galaxies where there should be none. Mature stars in a universe barely born. Black holes too massive, too early. Filaments already stretched across space-time. When the paint was still wet, the model didn't bend. It cracked. Like trying to measure the depth of an ocean with a ruler made for deserts. Like using earthbound logic to decipher a language never spoken by humans. Because that's what we've done. Our cosmology, for all its genius, was carved from the assumptions of our own world. Linear time, gradual complexity, cause preceding effect. Patterns that make sense to beings who evolved in forests, not voids. Who count in decades, not eons. Who dream in 3 dimensions and fear the dark. But the universe isn't bound by our instincts. It doesn't need to make sense to us. James Webb, with its golden eyes and silence deeper than prayer, has revealed not just anomalies, but a questioning of the questions. Maybe the CDM model isn't wrong in its equations, but in its framing, maybe the way we model dark matter as passive scaffolding misses its deeper role. Maybe dark energy is not a force accelerating expansion, but a property of space itself, pulsing with dynamics we've yet to imagine. Or perhaps the most disturbing thought, maybe our entire structure of understanding of beginnings, middles, and ends is Earth's story, not the universe's. We look out and see contradiction. But maybe what we're seeing is freedom, the universe refusing to be pinned down by metaphors carved from clay. There is humility in this. A humility we've forgotten. We thought we could reduce the cosmos to equations. We thought the universe was waiting to be decoded. But what if it's not a code? What if it's a song? A song that began before rhythm, that loops through time like breath, that folds meaning into form, but not logic. We tried to model the universe as an engineer builds a machine. But maybe it's more like a garden, growing in ways that defy blueprint. Organic, recursive, alive. And in that realization, we confront a deeper question. Have we built our cosmology in our own image? We shaped it to fit our minds, our timelines, our expectations, our hunger for causality. We ask the universe to obey rules we learned from apples falling and stars twinkling. But what if it doesn't? What if the rules change with the scale? What if the laws of physics are emergent, not eternal? Then our models are not maps. They are mirrors. And what Webb shows us is not that we are wrong, but that we are small in our perspective. Small in our metaphors. Small in our courage to accept mystery. But being small is not failure. It is the beginning of wonder, because if our rulers cannot measure the ocean, then perhaps we must learn to swim. To float in uncertainty, to embrace contradiction, to love questions that have no answer yet. James Webb is not just a telescope. It is a confrontation between what we believe and what is. And in that confrontation, we are invited to let go. To release our grip on certainty, to see models not as truths, but as stepping stones. To admit that the universe is stranger and more beautiful than human logic can bear. And maybe that's the point. Maybe the universe does not want to be solved. Maybe it wants to be heard, felt, lived. Like music, like poetry, like a mystery that deepens the closer you get. So we revise, we rethink, we begin again, not from a position of control, but of awe, because in the ruins of our models, we find something far greater than prediction. We find wonder. We once believed the cosmos was nearly complete. A grand puzzle, most of its edges aligned, its center filling fast. Dark matter, dark energy, expansion, inflation mysteries. Yes, but ones we thought were shrinking in the light of our intellect. Science was moving, not into chaos but into confirmation, a golden age we called it. As if the universe was finally letting us in on its secrets, whispering its final verses into the ears of clever primates with telescopes and equations. We dared to think we were near the end of unknowing. That what lay ahead was refinement, not revolution. That we had seen the shape of it, this universe, and just needed sharper tools to polish the details. And then came James Webb, a telescope not just of mirrors and gold, but of revelations wrapped in silence. It did not just see farther, it saw before. It peeled back the veil on the earliest moments, opening a window into cosmic dawn, a time when light was young, when the universe was just beginning to remember itself. And what it saw was contradiction. Galaxies too massive, stars too mature, structures too ordered. A cosmos that, by all previous measures, should not exist in the form it did. Not yet. Not so soon. It was as if we had opened a book titled Answers, and found instead riddles not written in ink, but in hydrogen and helium, in ancient light and impossible shadows. What was once a story of certainty has become a spiral of questions. We are no longer piecing together a completed puzzle. We are discovering that the box lid, the picture we thought we were recreating, might be wrong altogether. Every answer Webb offered came wrapped in a deeper question. It didn't confirm our models, it cracked them. Not with explosions or disasters, but with elegance, with the silent testimony of ancient galaxies, glowing where none should be. Like finding cathedrals in a world where brickwork hasn't yet been invented. Like seeing old forests in a land freshly cooled from volcanic birth. As though the future had folded itself into the past, as though time itself had cheated its own rules. And in that disobedience, something sublime emerged, because this isn't just about redshifts or timelines. It's about our relationship with truth, with knowledge, with the aching human desire to know. We once believed the universe was a system, rational, mechanical, solvable. A cosmic machine whose gears we could map, whose laws we could write down like recipes. But Webb reminds us that the universe is not a machine, it is a mystery. Not the kind meant to be solved, but the kind meant to be lived. There is humility in this. And there is beauty. Perhaps the cosmos was never meant to be wrapped in a theory. Perhaps it resists the closure of human logic. Because to finish a mystery is to kill its wonder, to reduce the infinite to a checklist. And what if wonder is the point? What if the universe exists not to teach us, but to move us? What if we were never meant to master it, but to fall into its depths, like a song to drift in its rhythm, like stardust caught in gravitational poetry? Science is not broken. It is becoming. It is not failing, it is awakening. Awakening to a new paradigm, one that does not treat mystery as error, but as invitation. An invitation to step beyond certainty, to abandon the illusion of completeness, to embrace a cosmos not made of answers, but of questions so vast they echo across light years. We are not mapmakers anymore. We are explorers again, and perhaps this is where the real journey begins, because a universe without questions is a dead one, frozen, finished, forgettable. But a universe that deepens as we approach it, that defies clarity just when we think we see the whole, that breathes riddles into our certainty, that is a universe worth loving, worth wondering about, worth listening to. So now we face the cosmos, not as conquerors, but as poets, as dreamers, as children staring up into a night sky that stretches not just above our heads, but through us, a darkness that isn't empty, but pregnant with questions. And maybe that's the most profound discovery of all. Not that the universe is stranger than we imagine, but that it is stranger than we can imagine. Not that it hides its truths, but that it is truth, unfolding, rewriting, rebirthing itself every time we dare to look deeper. So let us look, let us wonder, let us not know. And in doing so, become part of the mystery, because the universe is not finished, and neither are we.